And who's up for round 2 of graphing polynomials? So, example 6 is pretty much the same thing as example 5. So if you thought you understood example 5, you're good to go. I encourage you to try example 6 on your own. So go ahead and pause the video and fast forward to the end and see if you get it correct. Okay, or also you guys, if you understand parts of this example problem, I totally encourage that you try those on your own. Okay, you learn a lot more if you guys do things on your own and not just like listen to what I do. Okay, but if you don't understand, there's nothing wrong with watching the whole video. I'm just saying if you think you've got it, there's no point in not trying, right? Okay, so we need to graph this lovely polynomial, but the first thing we have to do in order to graph it is get this thing into factored form. And also when it's in factored form, we find the zeros. And remember, if we can't factor something, we have to use the rational zero theorem, which I have 5 terms, so the only factoring technique I could try on this is group factoring, but it wouldn't work because with 5 terms, I can't put the same amount of terms in each parenthesis. Which group factoring, we have to group the same amount of terms, so that's not going to work. Okay, so let's do the rational zero theorem. Now, remember before we do anything, you got to find the GCF first, if there is one. Okay, which looking here, oh man, I bet you guys see it. What's the GCF? Holy hot dog, you guys are so smart. Our GCF is 2. 2 goes into every single term. Okay, now, the reason why I don't have an x here is because there's not an x in every single term. So x cannot be the GCF. All right, guys, let's get going. So let's factor the 2 out of our polynomial. Okay, so I'm going to divide each of these by 2. Whoops. Need to write f of x first. Jeez Louise, Miss Long. Write f of x first. So f of x equals 2, and I'm going to write what's left over after I factor out the 2 in this lovely parenthesis. So 2 divided by 2 will cancel out and turn into 1, so it'll be x to the 4th. All right, negative 8 divided by 2 is negative 4, so it'll be negative 4x to the 3rd. 4 divided by 2 will be 2, so I'm left with positive 2x squared. 8 divided by 2 is 4, so this will be plus 4x. And then lastly, negative 6 divided by 2 is negative 3. Awesome. Okay, so from now on, I do not go back to this. Okay, I look at what is left over, and this is what I'm going to use for my p's, q's, and p over q's, and also what I'm going to use when I start synthetic division. All right, guys, let's find the p's, the q's, and the p over q's. All right, which I'm going to make, it's a really short list, so I think I can squeeze it all over here. Okay, so my p's come from the last term, and my q's come from the first term. So my p's, what goes into negative 3? Well, the only thing that goes into 3 is 1 and 3. So plus or minus 1, plus or minus 3. My q, I don't see a number, so there's secretly a 1 in front. Okay, and the only thing that goes into 1 is 1. All right, I'm going to take all my p's and divide by my q. Okay, 1 divided by 1 is 1, and 3 divided by 1 is 3. So if you see, we have a very short list of zeros this time, which makes our life much easier when we're trying to narrow down this into factored form. All right, guys, let's start some synthetic division. I'm super pumped up. Okay, so I'm looking over here. So my highest exponent's x to the 4th. So I'm going to start with x to the 4th, x to the 3rd, x squared, x to the 1st, and x to the 0. Okay, and then I need to decide out of my zeros, so these are the ones I'm looking at right now. Out of my zeros, what should I put in the box? What's going to give me a remainder of 0? I agree, you guys. I think 1 is a great choice. Let's see what happens when we do 1. And before we do this, we need to write the coefficients before we forget. The number in front of x to the 4th is 1. The number in front of x to the 3rd is negative 4. The number in front of x squared is 2. The number in front of x is 4. And the number without the x is negative 3. All right, guys, let's get the synthetic division train on the road. Let's go. Bring down my 1. Multiply my 1 to the boxy. 1 times 1 is 1. Slide it over. Add down. Negative 4 plus 1 is negative 3. Negative 3 times my box is negative 3. Gonna add down. 2 minus 3 is -1. -1 times 1 is -1. Gonna add down. We get we get 3, sorry. And then, holy hot dog, 3 times 1 is 3. And -3 plus 3 is 0. Yay, we have found a factor. Yay. Okay, so we found a factor, which means that this is a 0. So x equals 1 is a 0. Yay. All right, so we spotted one of the zeros. One of our zeros is 1. So when x equals 1. So I know that that's one of our zeros. Okay, so let's continue to reduce down our factored form, which I go back to my most recent factor form. So I need to include the 2 in this next one. So we have f of x equals 2. Next, I'm going to write my 0 in factored form, which when x equals 1 is the 0. In factored form, it's x minus 1. All right, and then I'm going to write my depressed equation in a parenthesis. So we start with one exponent less than our highest, which is x to the 4th. So 1 less is x to the 3rd. So 1x to the 3rd minus 3x squared minus 1x plus 3. All right, now remember, you guys, if at any point you can factor your depressed equation, which this is our depressed equation. This is what we got from here. That was what was left over. Sorry. If at any point you can factor, do it. It will save you time. If you keep sitting here putting zeros into synthetic, you are wasting time. Okay, which I have 4 terms. So the only factoring technique we talked about with 4 terms is group factoring. So let's see if group factoring is going to work. Okay, so since I have 4 terms, remember when you have 4 terms, you need to group the first 2 and last 2. Always will work. It will always work when you do it that way. Okay, so we're going to do some group factoring right here. Alright, so I'm going to group my first 2 terms, my x to the 3rd minus 3x squared. And I'm going to group my last 2 terms, my -1x and my 3. Alright, so remember group factoring, got to factor out the GCF. Okay, the numbers, there secretly is a 1 here. The only thing that goes into 1 and 3 is 1, so that's not going to work. But I see an x in each term, and the largest amount of x's that will go into 3 x's and 2 x's is 2. That's the most I can grab from each term and end up with the same amount of x's. Okay, so this GCF is x squared. Let's see what we get when we divide that bad boy out. Alright, x to the 3rd divided by x squared, we subtract the exponent, so 3 minus 2 is x to the 1st, or just x. My x squareds will cancel, so I'm left with x minus 3. Alright, so remember, my goal is to get the same thing in this parenthesis when I get done. Okay, which if you see here, we're actually really close. Okay, I have a negative x plus 3 here, and a 1x minus 3 here. So, if you guys see, we're so close. The only thing that's different are my signs. This x is negative and this is positive. This is a positive 3 and this is a negative 3. So remember, when our signs are different but everything else is the same, we must factor out a -1. We must do that. Okay, so I'm going to divide by -1. Nothing else is in common between each of my terms, so -1 is my only GCF. Okay, so -1 divided by -1 will cancel out. I'm left with x. 3 divided by -1 is -3. Holy hot dog! Look, I ended up with the same thing. Awesome. So my final answer here, where we put the GCFs in one parenthesis, my GCFs are x squared and my -1, so it'll be x squared minus 1. Alright, and then in the other parenthesis, I put what was the repeated term, so my x minus 3. Okay, so I have x minus 3. So we have factored that, yes. Okay, so I'm going to write what we have from here up here. So this will go to, alright, so we start with what we had originally, which is this 2 times x minus 1. And then we just factor this. And what we got was x squared minus 1 and x minus 3. Alright, but guess what, you guys? We can keep factoring. Okay, if you see here, the only one that I can factor is this one right here. Bam. Okay, and I can factor that through a difference of two squares. And the way I know that, you guys, I'm subtracting with two numbers, so difference is in the name. All right, and x squared and 1 are perfect squares, so I know I can use a difference of squares. Okay, so this one I'm going to do a difference of squares on my x squared minus 1 right here. Which, if you guys, again, remember, if you know how to do any of these factoring techniques, I encourage you to try it on your own. Okay, so difference of squares, remember to get the a, we square root our first term. And to get the c, we square root the second term, but do not include the negative. So we're going to square root 1. The square root of x squared, well, remember there secretly is 2 here. So 2 divided by 2 will give me x to the first, or just x. And the square root of 1, what times what gives you 1? Holy hot dog, you guys are so smart. It is 1. And then my final answer tells me to do a plus c times a minus c. So this will be x plus 1 and x minus 1. Okay, you guys, so final factored form. At this point, we cannot factor anymore. Okay, so my final factored form will be f of x equals 2. All right, now, so we reduce this one down to x minus 1 and x plus 2. So this one's secretly x minus 1 and x plus 1. Okay, that's what this one is. So if you see here, you guys, we have 2x minus 1. So remember, I can simplify that and write x minus 1 squared. Okay, and then I'm left with an x plus 1 and an x minus 3. Oh man, wasn't factored form exhilarating? It was quite exhilarating. Okay, so we have factored form. Now we need to back up here to our zeros. So let's think back to the degree. My highest exponent I see is 4, so I should end up with 4 zeros if I did this correctly, which so far I only have 1. So remember, when we're in factored form, you just take the opposite sign of what's in your parenthesis. So the opposite of negative 1 is positive 1, and since my multiplicity is 2, there are in fact 2 1s. Okay, the opposite of positive 1 is negative 1, so I have a 0 at negative 1. And the opposite of negative 3 is positive 3. So yay, I did end up with 4 zeros. Holy hot dog. Okay, next it says to plot the x value. So that's what I'm going to do next. Okay, I have 1 at 1. I have an x at negative 1. And I have an x at 3. And again, we plot these on the x-axis. So on the x-axis is where you plot these. All right, now multiplicity, we write how many times the 0 repeated. Okay, so when x equaled 1, I have 2x equals 1. So the multiplicity is 2. Or you can look here, the factor that pertains to x equals 1 is x minus 1 squared, so the exponent is a 2. Okay, when x is negative 1, I only have 1 negative 1, so the multiplicity is 1. Or when x plus 1 is the factor that relates to this, the exponent is 1. All right, and then my final 0 is when x equals 3. All right, and here, when x equals 3, the exponent is secretly a 1. This is the factor that pertains to this 0. Also, I only have a 3 listed 1 time, so the multiplicity has to be 1. All right, and then remember, let's talk about what the multiplicities are. So, since this multiplicity is an even number, remember at even multiplicities, the graph will be tangent. And these two have an odd multiplicity because they're both 1, which is an odd number. So at these two zeros, it will cross through. So I'm going to label that on here so it helps me when I'm graphing, so I know exactly how the graph is going to behave. Okay, so at positive 1, it will be tangent, so I'm going to put a T. At negative 1, it will cross through, so I'm going to put a C for cross through. And at 3, it will also cross through. Okay, now, we also need the y-intercept, which you can choose to substitute it into factored form or standard form. I don't care which one you do. I'll show you both ways, but you get to pick. So I'll start by putting it in here. So everywhere I see an x, you guys, I'm going to turn that thing into a 0. Okay, so we have f of 0 equals, all right, I see a 0 there, so it'll be 2 times 0 to the 4th. And then minus 8 up, I spot another x, so that'll turn to 0, minus 8x to the 3rd, or minus 8 times 0 to the third. All right, and then plus 4 times 0 squared plus 8 times x, so 8 times 0. And then finally, minus 6. All right, guys, let's see what happens. 0 to the fourth is 0, and 0 times 2 is 0. All right, and 0 to the third is 0, and 0 times negative 8 is 0. 0 squared is 0, times 4 is 0. 0 times 8 is 0, and then minus 6. So guys, what we get for our y-intercept is negative 6. So y equals negative 6, or you can write the point 0, negative 6. Nice. So this is our y-intercept. Okay, I'll show you in factored form over here since I'm kind of out of space. So this is the y-intercept. I'll abbreviate it with y-int. Okay, so I'm going to be substituting this thing into here. So I'll show you how that works. Okay, so we have f of 0 equals 2. Anywhere I see you next, it's going to transform into a 0. Okay, so 2 times 0 minus 1 squared times 0 plus 1 times 0 minus 3. So f of 0 is 2. 0 minus 1 is negative 1. And negative 1 squared, negative 1 times negative 1 is positive 1. 0 plus 1 is 1. And 0 minus 3 is negative 3. Holy hot dog. All right, guys, so let's see what happens when we multiply. So 2 times 1 is 2, times 1 is 2, and then 2 times negative 3 is negative 6. So if you see, we still get the same thing. Isn't that cool? So again, you can choose whichever form. If you like to substitute into factored form, you can do that. Or you can substitute it into standard form. Does not matter. All right, guys, I promise we're almost done. We're almost done. Okay, so the leading coefficient, okay, I can look in two spots. I can look in factored form. The number at the very start is the 2. So my leading coefficient's 2, which I'm running out of space, so I'm going to write it there. Or I can go back to standard form, which I kind of crossed it out, but the number I see with the highest exponent is a 2. Right there. Bam. Okay, so my leading coefficient is 2. Now remember, you guys, the leading coefficient tells me where my final arrow is going to point. Okay, so since it's a positive 2, my final arrow is going to point upward. All right, and then the degree tells me, do the arrows point the same direction or opposite directions? Let's see what will happen. So my degree, my highest exponent I see is a 4. So this is a degree 4, which means it's even. So my arrows point the same way. So if my first arrow or my last arrow points upward, that means that my first arrow will also point upward. And guys, you can also get the degree from factored form. Remember, you add up all the multiplicities. So 2 plus 1 is 3, plus 1 is 4. Or just add up the exponents. 2 plus 1 is 3, plus 1 is 4. All right, so I know that both of my arrows are going to eventually point upward. Nifty. All right, so let's see what happens. At this point, we should have enough information to sketch the graph, except don't forget, you guys, we do need to plot the y-intercept. That's why we find the y-intercept, so we have another point on our graph to plot. So the y-intercept tells me where the graph smacks the y-axis. It smacks it at -6. So I'm going to go down to -6, 1, 2, 3, 4, 5, up. Made my graph too small. Should go down to -6. Sorry, guys. Okay. Let's sketch this thing and see what will happen. Okay, so I'm going to start upward. At this one, it's going to cross through. Okay, so it's going to cross through, come down, hit the y-intercept, turn. Remember, always turns before it gets to the next 0. Now, this one is going to come up and bounce off of it because it's tangent. Okay, so it's going to turn, come up, bounce off because it's tangent. Okay, and then it's going to kind of turn again. And this time, C means it's going to cross through. Bam! Isn't that cool, you guys? It's the W graph. Whoa, I love graphing these. They're so much fun. All right, and this graph's name is going to be, it needs to be a W name because it looks like a W, right? So this graph's name is going to be named Wally. Wally. Nifty. All right, so you just got 2 more parts and then we're done because we already knocked out the graphing part. All right, so in behavior, you guys, remember, we always put this down. what's the graph doing on the left-hand side? What does the graph do on the right-hand side? Which, it doesn't matter which one you put first. If you want to put the negative, then the positive, or the positive, then the negative, it doesn't matter. So on the negative side of the x-axis, you are asking yourself, where is my arrow pointing? It's pointing up. Holy hot dog. So f of x is headed to positive infinity. All right, and then on this side, on the positive side of the x-axis, so on the right-hand side, where is the graph pointing? It's pointing up to positive infinity. So to infinity and beyond with Buzz Lightyear. So f of x is going to positive infinity. Nice. All right, guys, the last step is the domain and the range. So the domain, we ask ourselves, how far left does the graph go? Okay, which this is going to get wider and wider, you guys. So it is going to cover all the negative x's since it gets wider and wider. So we write how far left and then how far right. So it goes to negative infinity. And then how far right, so if it gets wider and wider, it will head to positive infinity on the right-hand side. So this one will be positive infinity. And since I covered all my x's, the inequality notation would be x is all real. And guys, for polynomials, this is always going to be your domain. It's always x is all real because your polynomials always get wider and wider. Alright guys, I'm sad because it's the last part of the problem. After that, we'll be done with this epic problem. I hate when long problems come to an end. It just ruins my day when it's over. Alright, so finally the range. I don't want to do it because I don't want it to end. Okay, the range, we say how low does the graph go and how high does the graph go. Okay, so how low does the graph go? Well, it only goes down to this point right here, which we said that was at -6. So the lowest y value is -6, and since it can equal it, since it's at a point, remember we do need a bracket. So it goes down to -6, and then how high does it go? Well, it's pointing upward on both sides, so it's headed to infinity and beyond with Buzz Lightyear. All right, now inequality notation. We know we're dealing with y's, and we know we're dealing with the -6. So you have to ask yourself, are these values larger or smaller than -6? These numbers are larger than -6, and we can equal -6, so y will be greater than or equal to -6. And remember, you guys, you either pick these two to use or these two. Don't intermix them. They don't like to be combined. All right, you guys, that's it for this problem. I'm sad it's over, but I had so much fun. I hope you guys enjoyed it as much as I did, because it was awesome.